This video will describe how to provide high availability for Tacker and how it works in our monitoring tool. Why do we need high availability for Tacker? Right now, in existing implementation of Tacker, it can only run in single instance, so it has potential single-point failure. To overcome this shortcoming, we propose a active-active to Tacker's demo. The left figure shows the default configuration of Tacker in OpenStack. The client always needs to first arrive at Keystone to acquire the authentication token, and then use this token to access Tacker service. Finally, related operations are recorded in database. The right figure explains how to extend the original model to support high availability by using active-active configuration. We set up two Tacker services and two database services on two independent servers. Behind the Keystone, we use HA proxy as a load balancer to distribute incoming requests to two Tacker servers. The default load balancing policy is round-robin. At the same time, two databases are using master-master replication. In order to check how Tacker works with high availability support, we need to first introduce our monitoring tool. Let's see the monitoring tool, which is actually a web page. On this web page, we could check the running state of two Tacker servers. On the top half of this page is a chart that shows the number of requests received by each Tacker server. The horizontal axis represents the timeline, while the vertical axis represents the number of requests per second. The blue line represents server 1, and the red line represents server 2. By default, this chart is refreshed every 2 seconds. Right now in the chart, it displays the most recent 50 time points. We could change it by using window size. For example, we could set it as 20. We can also set it as 100, just according to our requirement. Now let's set it back as 50. Time filter is the option to select time points more precisely. We could set the start time point and the end time point. The format of input should follow the example here. For example, we can set start time as and set end time as. Then apply the filter. Now the chart only displays the points in the range of our filter. If the end time is left as blank, it is treated as current time, which means it displays all the time points from the start time till now. If the start time is left as blank, it is treated as from the very beginning. It displays all the time points from the very beginning till the end time. We can use clear button to cancel the filter. The chart returns to default state. Below the chart, there are two text boxes that are recording the real-time log for each server. There's a small block above the text area, which is used to show the status of text server. If the block is green, it means the server is working fine. If the server is down, this block will turn red. We can also check the history of log by scrolling, and by default, in each text box, the maximum number of lines is 100. In each line, the timestamp comes first, followed by the log message, and then the sequential number of this message. Now we can check how high availability Tacker works. Now let's see what happens when one Tacker server is down. At first, Both two servers are working fine. We can see that the requests received by each server are close to each other, and some points are overlapped, because we are using round robin as default policy of load balancing. Now we shut down server 2. It usually takes around 10 seconds to confirm that server 2 is down. This delay is caused by our detection policy. We define that only if the server continues to fail for 5 times, we treat it as inactive. The check interval is 2 seconds, hence 10 seconds delay. Of course, we could change the policy based on various scenarios. Once confirmed that server 2 is down, the small block turns red, and the server 1 starts to handle all requests. From the log of server 1, we can also see that server 2 is inactive, and right now the number of active servers is only 1. From the log of server 2, it stops updating since it's already done. Now we restart server 2. It will take 6 seconds for load balancer to detect it. We can see that the small block turns green, which means server 2 is back. The requests are redistributed to 2 servers again. In the log of server 1, the number of active servers is 2, and the log of server 2 starts to update again.